Hello everyone, welcome back to Vishwavidyalay. Today we are going to learn one of the most important topics in physics, that is Newton's laws of motion. These laws are given by Sir Isaac Newton, a famous scientist, and they explain how and why objects move or stay at rest. Everything around us, walking, driving a car, playing cricket, flying an airplane, follows Newton's laws. These are three laws of motion, and we will explain each law in detail with simple examples. Now let us know the first law of motion, that is law of inertia. An object remains at rest or continues to move with uniform speed in a straight line unless acted upon by an external force. This law tells us that if an object is at rest, it will stay at rest. If an object is moving, it will keep moving at the same speed and in the same direction unless a force is applied to it. This natural tendency of an object to resist changes in its state of motion is called inertia. Now let us examine everyday examples. Book on a table. A book kept on a table does not move by itself. It remains at rest until someone pushes or pulls it. Now let us see the second example. Sudden stop of a bus. When a moving bus stops suddenly, passengers fall forward. This happens because their body wants to continue moving forward due to inertia. Now let us see another example. Dust from a carpet. When we beat a carpet, dust particles fall off. The carpet moves suddenly, but the dust particles remain at rest due to inertia. Now let us know the types of inertia. Inertia of rest means a resistance to start moving. Inertia of motion means resistance to stop moving. Inertia of direction means resistance to change direction. Now let us learn the second law of motion. The rate of change of momentum of an object is directly proportional to the force applied and takes place in the direction of the applied force. This law explains how much force is needed to move an object. Newton expressed this law using a mathematical formula, that is, force equal to mass into acceleration. In short, F equal to ma. What does this mean? A greater force produces greater acceleration. A heavier object needs more force to move. Acceleration happens in the direction of applied force. Now let us learn everyday examples. Kicking a football versus kicking a stone. When you kick a football, it moves easily, but kicking a stone hurts and barely moves it. Why? Because the stone has more mass. Now let us see another example. Pushing a shopping cart. An empty cart moves easily. A loaded cart needs more force to move. Now let us see another example. Cricket or baseball. A fast bowler applies more force, so the ball gets more acceleration and moves faster. Now let us learn the importance of second law. Used in vehicle design, helps calculate braking distance, important in sports, engineering, and space science. Now let us know the third law of motion. For every action, there is an equal and opposite reaction. This law means that forces always act in pairs. When one object applies a force on another, the second object simultaneously applies an equal force in the opposite direction. These forces act on different objects so that they do not cancel each other. Now let us know everyday examples. Walking. When we walk, our feet push the ground backward. The ground pushes us forward, helping us move. Swimming. A swimmer pushes water backward. Water pushes the swimmer forward. Rocket launch. Hot gases are pushed downward. The rocket moves upward due to the reaction force. Gun recoil. When a bullet moves forward, the gun moves backward. Why don't action and reaction cancel each other? Because action force acts on one object, reaction force acts on another object. So both objects move independently. Now let us know the applications of Newton's laws in daily life. Seat belts protect us due to the first law. Airbags reduce force using the second law. Jet engines and rockets work due to the third law. Sports techniques depend on all three laws. Now let us summarize the Newton's laws of motion. First law explains why objects resist change, that's inertia. Second law explains the relationship between force, mass, and acceleration. Third law explains how forces come in action reaction pairs. Newton's laws of motion form the foundation of classical physics and help us understand the motion of everything around us. So that's all about Newton's laws of motion. We've learned how the first law explains inertia. The second law shows the relationship between force, mass, and acceleration. And the third law tells us that every action has an equal and opposite reaction. These three simple laws explain almost everything that moves around us, from walking and driving to sports and rocket launches. If you found this video helpful, hit the like button, share it with your friends who are studying physics, and subscribe to the channel for more easy and concept based learning videos. If you have any doubts or topics you want me to explain next, drop a comment below. I did love to help. Thanks for watching, and I will see you in the next video.